Brad Thompson, University of Tennessee, and we can start the clock. Thank you very much. So this talk is intended to be a setup for this session. This session is overview of the lunar map needs in the Artemis era, and the title here is supporting a new lunar geologic mapping campaign. And the take-home message, I think, of this talk and of this session really is that a new lunar geologic mapping campaign would benefit both exploration and science. So it's not just for Artemis 3, although it would benefit Artemis 3, but follow-on missions, other CLIPS missions. There's a menagerie of things going to the moon, and I think all of these endeavors would benefit. No worries. From a renewed lunar geologic mapping effort. So next slide, please. Thank you. So I'm going to take a brief minute and look back to the past and talk about some of the past map series, which many of you may be familiar with, but some of you might not be, the LAC series and other geologic maps, and then discuss some options for renewed lunar geologic mapping. So I'm going to talk about, of those three things listed there, the first two, and the third one will be Jim Skinner's presentation, dealt with in more detail later on in this session. Next slide, please. So the start of systematic lunar geologic mapping began with the LAC charts, Lunar Aeronautical charts. These are airbrush shaded relief maps that were initiated in 1959, which is notable. That's only 2 years after Sputnik scared the living heck out of the science community. And there was a concerted effort by NASA and the DoD, by the Air Force and Army Map Service, to produce this ground-based shaded relief maps. And the goal wasn't really geology. The goal was just accurate locations, the physiography of where features are on the surface. As an example of one of these, next slide, is here. This is LAC 40 for Timocris. So it's a quadrangle. This is a Lambert conformal conic projection. And these maps are archived at LPI, at the RPIF, and elsewhere. And you can tell that it's basically just gives you a sense of the sort of the topography, the lay of the land, but not the geology. And these were later redone after the Lunar Orbiter mission provided orbital coverage of the whole moon. And then Ben Bussey and Paul Sputus redid these again with Clementine images in 2004, I think. Next slide, please. So here's an example of the systematic geologic maps that were done by the USGS. So starting with Shoemaker and colleagues in the Copernicus quad, and then going out from there, they were redone. These were done with lunar orbital images at a base. These are mapped at a scale of 1 to 1 million. So this is an intermediate scale, and that's notable because other speakers, for example, Laz yesterday mentioned the need for intermediate scale geologic mapping to connect the small scale geologic mapping, large scale, small area geologic mapping that the Viper team is doing with the sort of the global hemispheric maps at the 1 to 5 million scale, or even the 1 to 300,000 scale that Jim had presented yesterday that was published this summer. So as an example here, you can see, it's kind of hard to see in this cross section here, but this crater, Lambert, is a buried crater. So the makers of this map were able to infer quite a bit about the stratigraphy, about the 3D relationships of geologic units here, which is one of the real goals of mapping, of course, so that subsequent investigators who go in and do things like select landing sites have better context for where they might be landing. Next slide, please. So on this map here, I should say, this grid map here, this shows the LAC quadrangles system as laid out on the lunar near side. So there's 44 tiles here at 1 to 1 million scale. And these were mapped between 1961, and I think the last ones were finished as the Apollo program was ending, 1972, largely led by members of the US Geological Survey. And I think this is a template for what could be done in the future. But there's a couple of options for how one might do this. And I should point out, MapSit promulgated a finding on the need for lunar geologic mapping that I didn't stick in this slide deck, but that was at the June PAC meeting, and those slides are posted on the MapSit website. But next slide, please. So The first option would be to utilize LDAP. So the Lunar Data Analysis Program is an RNA line that has existed for many years now, and it includes the option to do geologic mapping. So I pulled some language out of here from the call. So studies may include, but are not limited to, investigations centered on new science questions, novel approaches, or scientific investigations to support current and future lunar exploration. And that last bullet there made it permissible to do, say, a map of a particular landing site. But the catch is that while geologic maps are permissible, they must include a science investigation. So you can't just say, I want to map this region of the moon because it's important, because there's going to be some mission going there. And yeah, that's the reason I'm doing it. You have to have the map. All maps should be a tool, so they can be tools for both exploration and science. But the wrinkle with getting maps through the LDAP program is that they have to serve this science investigation. They have to be a tool that's used to address a question that's outside of just the creation of the map itself. And that means it's a kind of a higher bar to clear. Next slide, please. So as I just mentioned, based on language in the call, a proposer must have a science investigation. So the map must be done in support of answering a science question. And now that we have many years of data under our belts, my understanding is the mapping selection rate is not terribly high. And Jim Skinner could speak more detail here. But no new lunar geologic maps have been published through the LDAP program, even though a few have been awarded. Of my understanding is they're stalled in various stages of the production process. And that's not the fault of the USGS, that's the fault of the individual map PIs, because it's a PI-driven endeavor. And a notable revision of geologic mapping was the recent 1 to 5 million scale geologic maps. The line work was redone by Corey Fratezzo and colleagues at the USGS, but this was done outside the confines of the LDAP program. Next slide, please. The last thing I want to touch on, since I'm going to let Jim talk later about the third option, is something I want to point to: the Mars Critical Data Product solicitation. So I think this is a potential model for how to run a lunar critical data product solicitation. So there have been 10 of these between 2003 and 2016. They're archived here on the MEPAG site, and they're like a normal RNA call, but they're very small and targeted at specific needs. So some example ones here I called out was there was support of the initial landing site characterization of the Mars 2020 rover mission. So, and this wasn't just geologic mapping, it was in particular, they wanted some atmospheric studies to do better EDL, entry, descent, and landing modeling of the spacecraft as it landed. There was one for InSight that called upon proposers to characterize the potential landing site in various ways. And there was another one that was getting ready for comet sliding spring in 2013. So this comet was predicted to hit Mars, and what would that do to the near and short-term environments of Mars, and how might the current orbital assets be used to study it? So this proposal, this critical data product call, sought specific investigations that would facilitate that. So I think this is a model for how one could do targeted geologic mapping of individual sites. So the MEPAG model is very mission driven. So it's a particular mission says, hey, we need all the data or specific products for this particular location. It's good for that. It's probably insufficient for sort of the systematic geologic mapping approach, which Jim Skinner is going to talk about later. But the rub there is that those of you that have tried to follow the CLIPS landing site opportunities, Maria Banks for the LRO team has done the lion's share of the work in trying to compile this very detailed spreadsheet. And the problem that she as others have is that it's constantly changing, right? So companies' priorities shift, mission opportunities change. And so what that means is that people's focus might change. And I think a way that we as the community can help with this exploration effort is to perform a more systematic mapping effort that encompasses most likely the whole moon. So I see some chat there. I'm just about done, so I'm going to wrap up and we can transition to the next speaker.